All good. So I think we should be able to start now. So hi everyone, and welcome to this presentation, this workshop on the fundamentals of Git. It's actually the first event that the Deakin Software Engineering Club is hosting in 2021. So it's quite special. And so I'm Ravinder, and I'm the current secretary of the Deakin Software Engineering Club, and I study software engineering at Deakin. So let's go over the agenda for today. It's going to be what you see on screen right now. So we'll talk about what Git is in the overview. Let's have a look at how it will be installed on your computer and how you configure it before you actually start using it. Then let's talk about some really basic stuff like repositories and commits. Move on to a bit more advanced stuff like branching, merging, and conflict resolution. And finally, let's have a look at how we'd collaborate on Git projects using Git. So as you work on software projects, you'd want to do changes in a very controlled manner to your code bases because you don't want to break stuff, right? So you'd want to keep track of the individual changes that you do to your code base. You'd want to keep track of who authored those changes and when they authored them as well. And you could also want to do stuff like work on multiple versions of your code base simultaneously. So this is where Git comes in. It's what's known as a version control system, and it simply keeps track of changes that you make to your code base over time. So it's very widely used. It's in fact the most widely used version control system, and it's also free and open source, which is really cool. Their official website is gitscm.com. So the way you install Git on Windows is a bit more involved than on other operating systems. On Windows, you'd visit gitscm.com/download/win, and you download their installer and run it, and you should be fine. On Linux and macOS, installation could really not be simpler. Literally run like whatever command whatever the command is for your package manager. So if you use Homebrew, it's brew install git. And depending on the distribution of Linux that you run, it will be something like apt install git or dnf install git. So once you're done installing Git, you can verify if you've installed it successfully by running git-version. So the output will look something like this on Windows, and on Linux, it'll look something like this. And once you see this, you should be good to go. Before you start using Git, though, you might want to run a bit of configuration. So you'd identify yourself to Git. So you'd specify your username and an email. So this isn't used to log into any service. It's literally just used to keep track of who made changes in your code base. So in my case, I'd run git config global user.name and type my name. I do user.email and type my email address. And that should be it. You'd also want to specify what's known as a default branch name. And we'll get to branches in a minute, but you'd want to use the init.default branch option and specify the default branch name to be something like main. Conventionally, main is what you'd use. So you do git config global init.default branch. And then you'd want to also specify the text editor that you'd like to use. Because sometimes you'd want to interact with Git using a text editor instead of always the terminal. So in this case, that's what you'd want to specify Visual Studio Code as the text editor that Git uses, but you can specify it to be anything really. So once you've configured the Git, you should be good to go to actually start working on your projects. So a bit of terminology before we dive in. I mentioned earlier that Git keeps track of changes in your code base. A repository is a folder in which this happens, right? So if you want your project to be version controlled with Git, you'd want the source code of your project to be inside a repository. And then committing is simply saving changes to your repository by making like a checkpoint. So it's kind of analogous to how in video games you'd kind of save your progress before kind of playing like a challenging bit so that you can always revert to that state. So that's what a commit is, really. So an advantage of using Git in this context is that if you commit your changes, you can always be confident that you can like revisit that version of your project. So you don't have to ever worry about like permanently breaking something. So yeah, let's dive right in, actually. Let's start off by creating a repo. As I said, a repo is simply a folder. So that's what we're going to do. We'll make a folder on my computer, in this case, called my project, for example. And you'd want to cd into that folder, cd being change directory. So you've made the folder. What you'd want to do now is initialize the folder as a Git repo, and the command for that is git init. And the output of it would look something like this. The difference between a Git repo and an empty folder is really this folder within the repo known as .git. So if you have a look at the hidden files within this folder, you'll notice that there's a file called .git. So on Windows, if I open this in File Explorer, you'll not see anything. But if you view hidden items, you'd actually see there's a .git folder, and this is what Git uses internally to kind of keep track of changes and whatnot. We'll not go into how this folder is structured, but bear in mind that if I remove the .git folder, so on PowerShell, you'd remove the .git folder like this. So this is no longer a Git repository. So if I do git status, you'll notice that it says it's not a Git repository. So once again, let me init the repo, and this is a pretty good place to start our project. That is version controlled in Git. So I might just open this project in Visual Studio Code. And to do that, I'm going to open VS Code. I'm going to open the folder that I made, which is on my desktop, my project. And let's go ahead and make a small change. So let's start off by creating a file called index.html. And let me add a bit of code which I've pre-written, which is a basic, boilerplate HTML file with nothing much on it. So there's a command called git status that you can use. This is a pretty important command because it shows you what Git understands about your project. Yeah, this is where the whole tracking comes in. So it understands that there's a new file called index.html that it isn't tracking yet, but we'll get into that a bit later. So I'm just going to start index.html in the web browser. So obviously it doesn't really have much on it. Cool. So now we've made some changes to our project. We want to commit these changes now to save our changes as a snapshot in the timeline of our repo. So that's where commits come in. And committing is a two-step process. So if you look at git status again, as I said, there's an untracked file called index.html. When you commit something, you'd want to stage your changes first. And staging is simply the process of marking changes to be included in a commit. So staging is done using git add. So you do git add index.html. And if you type git status again, you'll notice that, okay, Git now knows that there's a new file called index.html. And the next time you make a commit, this new file, will be added to the commit. So once you've staged your changes, what you'll do then is you'd commit your staged changes. So you do git commit. And then you'd specify a commit message, which kind of describes the changes that you're making. So in this case, I'll call it create index.html. And like that, you've made your first commit. So once again, the project directory doesn't look any different to what you'd expect. Like it literally has an index.html file and the .git folder, which you wouldn't see by default. But Git now knows that, but you've made a commit, and Git now is aware of that change. And Git is keeping track of changes to this file. So once you've made changes, you can view a list of changes using the git log command. And this list is known as the commit log. So you'll notice that when Git keeps track of changes, it keeps track of like who made the change, so the author, and the date and time on which the change was made, and what's known as a commit hash, which is a unique identifier for a commit, and also the description of the commit or the commit message that you specified via the -m parameter. Yeah, and then if you want to view the actual changes that happened in that commit, you could do git show and type the hash of the commit, which I said is the unique identifier of the commit. So you could do git show and then the hash to show what changes were made. So in this case, we added a new file called index.html, and the changes were these lines of code. So does that make sense to everybody? If you could like thumbs up on Teams, that would be really nice. Oh, all good. Awesome. So we've made a commit at this point, and note that this is what's known as a diff. Diff stands for difference, and a diff is basically a representation of how something in your code base has changed. So in this case, this is the diff of index.html, and we see that Git knows that these lines have been added, which is why we see the little plus sign. So that, again, was the git show command. So a bit about commit messages. You have to keep commit messages very focused and very succinct. So a commit message is generally of this format. So you'd have the first line of the commit message, which is known as the commit message header. And then you've got subsequent paragraphs. That form what's known as the body of your commit message. The commit message header is what you see in the git log command if you use the one-line flag. So it's a very succinct description of the changes that you made in your commit. And then if you want to elaborate on your commit message, so on the changes that you did, you can go ahead and use the paragraphs for it. And let me show you an example of how you'd actually use an extended commit message as such. So I'll go ahead and make another change in our code base. And this time I'll add what's known as an editor config file. So the editor config file is a file called .editorconfig that sits at the root of your code base. And this literally just specifies a bunch of settings that you'd want your text editors to kind of comply to. So in this case, I'd say the character set is easy of 8. I want to indent using tabs. I want to insert like final new lines, and I want to trailing white space, so that if I kind of have trailing white space in my file, it'll all be removed when I hit save. It's a pretty useful file. Their website, the website of the standard, is at editorconfig.org, so it's pretty useful to kind of add one of these to your project. So, but I digress. Anyways, we've made a change, and that change is we've added an editor config file. Once again, git status is your friend to kind of reorient yourself in terms of what changes have been made in the repo. And we see that, again, we've got an untracked file. And if I revisit the slide about actually making commits, is that commits are a two-step process. So we want to add this file, and we'd use .editor config for that. And then we commit this file using -m. And then in my commit message, I could do something like add editor config. But I wanted to kind of specify an extended commit message that includes both the header and the body, so kind of to elaborate on this change. So instead of kind of specifying the -m file, I could specify a git commit -e. So this will open a text editor. So in this case, it'll open Visual Studio Code because that's what I configured Git to use. And now I can go in and specify a proper extended commit message with a bit of a description as well. So I could say add editor config is the header of our commit message. And then the body of my commit message could be something like the editor config, a description of the editor config standard, and maybe a link to this. You don't have to elaborate on every commit that you do, but it sometimes helps, particularly if your commits are pretty advanced or like big. So once you close your editor, you'll notice that it actually commits. And if you view the git log again, you'll notice that the commit's there. Once again, you could do git show and then the hash of your commit to actually see the changes that were made. And in this case, a new file is added called editor config, and these were the actual lines of code that were changed. So I hope everyone's all good at this point. Yeah, let's go ahead and make a couple more changes to our code base. So we've got an HTML file that we're working with. I'm going to add a couple of paragraphs with of different colors. So I might do like 3 paragraphs. So one of these will have cyan text, the other one will have magenta text, and the other one will have like yellow text. We've used a bit of CSS here, so I'm going to make a bunch of CSS files called cyan.css. This will have the text cyan class. Likewise, I'll just make a magenta and a yellow.css file. So a magenta.css file with text in it, and a yellow.css file with text yellow in it. And in index.html, I've included a bunch of paragraphs with those classes, and I'll also include a bunch of links to those CSS files, so that if I reload the web page, you'll notice that we've got a bunch of barely readable, but cyan, magenta, and yellow text. So let's have a look at the git log at this point, git status. You'll notice that git detects index.html to be modified, and git detects the 3 untracked, the three new files that we actually added. I'm going to go ahead and make another change to this. I'm going to add a bit of interactivity to my page. I'd say something like in greet.js, I'll add a function called greet, and then in index.html, I'll also add a bit of code to display a button and call it function when it's clicked. So if I reload the page, it'll do something like this. Pretty simple. So at this point, I'd want to commit these changes, but if I go back to like the previous slide about commit messages, remember how commit messages would ideally be focused? So I want to divide these changes into 2 commits. So that's what we'll kind of discuss now. Again, since committing is a 2-step process where you'd first stage your changes to be committed, and then you'd actually commit them, Git actually makes this pretty easy to do. So remember the command to actually stage changes, which was git add. We can use the -e flag with that change. This shows us all of these change files. I could do git add with that file, but then I could specify the -e flag to specify what changes I want to actually be staged. So in this case, I'd want to break my commit into two commits. I'd want to say something like, I want to do one commit as add CMY paragraphs, and I'd want to do a second commit as greet user in index.html. So let's focus on our first commit here. So each of these is a two-step process. So we'd have to stage these first, and then we'd have to actually commit. So we've made these changes. Git knows that we've modified, but we want to stage a subset of our changes to index.html. So what we do is git add index.html, but then we do -e, and then this lets us pick what lines of code we want to actually stage. So in this case, since we're focusing on the assign, magenta, and yellow changes first, I'd remove greet, the lines of code here, save it. And you'll notice now that Git shows index.html in two kind of sections. So this is the section for changes that aren't staged, and that's the section for changes that are staged and therefore will be included in the next commit. So if you want to view these changes, you can use the git diff -cached command. So if I do git diff cached, you'll notice that these are the changes to index.html that will be included in our next commit. And these changes don't include the greet changes that we did down here. So we've basically broken our change down into a small kind of subset of it. So along with this change, I'd want to also commit the CSS files. And again, I could do git add, and I could specify cyan.css, magenta.css, and yellow.css as well, because it takes multiple files. But in this case, I could also specify everything.css. And if I do git status, you'll notice that in the changes to be committed, there's our modification from before, and the cyan.css, magenta, and yellow.css files as well. So I can commit this as add cyan, magenta, and yellow paragraphs to index.html. So the changes that we're left with are the changes related to greeting. So what we could do is git diff do those changes. So in this case, in index.html, we see that the changes that remain relate to the bit of interactivity that we added to our web page. So I can go ahead and add all of this. Git add everything, by the way, adds all changes that remain. So in this case, both index.html and greet.js. And git commit -m, and I'll say greet user in index.html and commit. If we have a look at our git log, we've actually made the changes that we did together, we've committed them as two separate commits. And if I git show this, you'll notice that this only includes the changes that we've made to add the cyan, magenta, and yellow paragraphs. While if I do git show this commit, git show that, this includes only changes where we've added the interactivity to our web page. Do you have any questions right now? Thanks. So at this point, we've made a number of commits. And as I said, they're all visible using git log. So now let's talk about the commit graph. The commit graph is basically a chronological representation of the commits that you've made. So in this case, it's chronological from bottom to top. So create index.html represents that commit, and so on. And each node in a commit graph represents a commit that you made. We could also make another small change to our project. We could do so we've got a whole bunch of files in our root. I'm going to separate these files into folders. So I'm going to move my CSS files into the CSS folder, and I'm going to move my JavaScript file into my JavaScript folder. And again, so we've made a change, so we've got to commit it. Let's have a look at the status. At this point, we see that the way that Git understands changes is a bit weird. So in our case, it's intuitive to us that we've moved our files, but Git understands it as us having deleted our files and us having added a bunch of new files to our project. But you'll notice that if I add everything, so that's stage all of these changes to be committed and run git status, Git actually identifies that this has been moved and not actually deleted. So the diff that you see might not always be the most intuitive thing, but it's always equivalent. So whenever you change like a word, a letter, for example, so if I delete this word there, Git understands this to be removing the line that says this web page and adding a line without the actual commit, without the actual word. But we'd obviously understand this to be as just removing this. But obviously, the point is that this is equivalent to removing that. So it's just something to bear in mind. Anyways, so we've staged these files. I'm just going to commit this as move CSS and JavaScript into separate folders. And if I git log, you'll notice that we see our commits. And once again, I could git show and look at the actual differences in that file. We actually forgot to do a little thing. So at this point, our project is kind of broken because we forgot to change the paths here. So let me just change them right now. And I might just commit these as well. So git log. I'll say, so git add all my current changes and git commit. I'll say fix paths of index paths to CSS and JS within index.html. And by the way, I can also, I might have not mentioned this earlier, remember how while committing, you could specify the -e command to actually open the editor. If you don't want to do this, you can specify multiple -m flags to add separate paragraphs. So in my case, I could do errata of this previous commit, just to refer to it. And you'll notice that if I git log, it's actually added 2 paragraphs, just like we use the editor to add 2 paragraphs over here. So it's you could do it either way. Is everyone okay up to this point? We covered commits and commit messages and staging. Does anyone have any questions about any of that? Looks like we are all good. So let's continue on to branching, which is relatively advanced. So once again, we've got this commit graph that we're working with. A branch is it's simply a sequence of commits, right? And the current sequence of commits that we have, that is the sequence of commits that the git log displays over here, forms what's known as the default branch. Okay? Now, you can deviate from the sequence of commits to make commits that are kind of isolated from the default branch. This is what's known as branching off the default branch. Okay? Now, you can always switch between branches and make commits on like any branch you want, any branch you want to target. So in this case, I've switched off the default branch, made 2 commits on the default branch, switched on to the default branch again, made a commit there, and then I could also switch back into the second branch, the blue branch here, make another commit on it. And finally, when I want to incorporate these isolated changes into my default branch, I could do what's known as a merge. So branches have names. So obviously there's the default branch, and that's obviously a new branch. Let's go ahead and create a bit of a branch in our repo. There's a command called git branch, by the way, that lists the branch that you have, and the branches that you have, and the default branch is known as main. if you want to create a new branch, you can use the git branch command, but you can specify a name for the new branch that you want to make. So in this case, if I want to maybe add a feature to my project where we add a bit of a calculator to this web page to like add 2 numbers, I could do a new branch called adder. So if I run git branch again, you'll notice that we've made a branch known as adder. Now, once you've made a branch, you've got to switch to it, and that's done using the git checkout command. And you'd specify the name of the branch that you want to switch to. So in this case, we'd want to switch to adder. If you want to do both of these together, that is, if you want to create a branch and you want to switch to it together, like in one command, you could use the git checkout command, but instead of specifying the name of the branch on its own, you'd specify git checkout-b and the name, and it should actually create the branch for you and automatically check it out for you as well. So let's make a couple of commits on our adder branch. So let me actually go back to the git graph, the commit graph that we had earlier. So we were at this point. We've branched off into our adder branch, and let's go ahead and make this commit now. And in this commit, I will simply edit index.html to include a couple of inputs to accept a bunch of numbers, and also a button that says equals, and then a span, which is a bit of a text area in HTML, a placeholder for text, known as adder results. So the page looks like this, and you're supposed to be able to type the numbers here and get the result over here. Obviously, we haven't added our adding logic yet, so let me do that now. And to do that, I'll make a file known as adder.js in the JavaScript folder and paste a bunch of code that I've pre-written. So in this case, all it does is it retrieves the input known as adder n1, that is this. Then it retrieves the input known as adder n2. And literally, when the submit button is clicked, it sets the text of the result to the value of n1 input plus n2 input. So let's commit this change as include adder in index.html. So let's go back to our terminal. Once again, we could do git status to view our changes. We see that git understands that we've modified index.html. We could do git index.html to actually view the changes that we've done. So sure enough, like the same changes show up here. And then we could do git add index.html again to stage these changes to be committed. Once again, we've also got this new file called adder.js, so I'm just going to git add js/adder.js. And I'm going to commit this as include adder in index.html. Let's have a look at if our calculator actually works. We'd say 3 plus 4. We'd expect to get 7, but we don't. Now, ideally, you'd test your changes before actually committing them, but in this case, we didn't. So let's make the second change over here. So we've made this change. We've branched off the default branch, and we've made that change. But we'll make another change that fixes the faulty adder that we added. And to fix this, I'm just going to head over to adder.js, and to fix it, I'm going to have to the reason our adder didn't work is because we're trying to add 2 HTML elements to each other and not their actual value. So in this case, what I'd want is the value as number on both of them. And if I head over to index.html again, you'll notice that this actually works just fine. So let's commit this change. git status again to see that, okay, we've modified adder.js. Let's view the changes that we've done. So we've added a bunch of comments, and these are type hints to Visual Studio Code that tell VS Code that, what kind of variable it is. So don't worry about any of this. But now notice that the change that we did was we added this dot value as number. Yeah, but as I said, Git understands this to be removing a line, removing the previous line, and adding a new line. So again, this change is equivalent to just adding this bit. But just bear in mind, this is how Git diffs are always line-based. So this is how Git understands it, understands your change. So once again, let's stage our changes, and let's commit our changes as fix adder logic. And I might just elaborate on why we fixed it. So I'd say fix adder logic as the header of the commit message. And I'd also elaborate on it like this. So use the actual value as the number instead of adding the elements to themselves. So let me close that window, and we notice that in our Git log, we see that the change is over here. It's all good. So at this point, we've branched off our default branch and made 2 commits on a separate branch. And this branch happens to be known as adder. Now, as I said, you can always change branches using the git checkout command. So in this case, we change into our main branch. So once again, git branch lists a branch. We're currently on adder. You can always change branches using git checkout. And when I change, you'll notice that the changes that we made on the adder branch, so that is adding the actual adder and then fixing that bug, don't appear here because those changes are isolated. So that's the whole concept of a branch. It's a parallel version of your repo that you can make isolated changes on. So we're on our main branch. We can go ahead and make a commit here. The commit that I'll make here is maybe something like, instead of, I could revise this paragraph to say it has a sorted content. So I just want to describe, demonstrate that you can actually make a change here. So once again, git diff shows us that we've changed this line of index.html. I could add everything and stage everything, that is, and commit this as update paragraph that describes content of index.html, for example. So we've branched off main, made 2 changes on this new branch. We've switched back to main and made a change here. I can switch back to my other branch. So I could, again, git branch shows us the list of branches. I could git checkout adder to switch to the new branch. And I could go ahead and make another change over here. And to do this, the change that I'm going to add here, that I'm going to make here, is I'll make a CSS file called adder.css. I'll link the CSS file in my index.html file called adder.css, and I'll write a bit of CSS to affect adder result. So it'll be something like .adder result, and I'll say something like add a bit of a font weight to it, specify a bit of a left margin, and well, show a shadow. So if I do 3 plus 4 equals, and interesting, so that didn't quite work. Oh, it's because that ought to be a pound sign instead of a plus. So 3 plus 4 equals 7, and you'll see that the actual changes that we did now, that is the CSS changes, have been added here. So I'm just going to commit this change as a new commit on my adder branch. So again, git status shows us that we've modified these files. Git diff shows us the changes of index.html. I'm just going to add everything. So stage everything using git add, and git commit -m, and I'll call this emphasize adder result, for example. So at this point, we've made 3 commits on our adder branch, And we've also made, in the middle of these 3 commits, we've made another commit on the default branch. So you'll notice that, as I said, branches are isolated. So if I switch between branches, you'll notice that only changes on those branches are actually shown because the files themselves are changed. So if I open VS Code, for example, this is the main branch, which means we see all the commits we did on main, including the web page as disordered content change, which we did over here, which was this commit. Then if I switch back to the adder branch, you'll notice that it now displays the changes that we did exclusively on the adder branch, so these changes and the adder.js file that we added. So at this point, we'd want to merge these changes into our default branch, and we do that using the git merge command. You'd first want to make sure that you're on the branch into which you want to merge. So what you do, git branch, and make sure that you're on main in this case, because we want to merge into main. Now that we're on main, we could do git merge and then specify the branch that we want to kind of pull in. You'll notice the git log. You'll notice that there's what's known as a merge commit that kind of Git automatically makes when you merge stuff. But now you'll notice that we're on the main branch. So if I do git branch, it says we're on main. But the changes that we did in the in the adder branch actually appear here as well. So that's how you'd kind of merge branches in Git, and how you'd branch off of the main branch in Git, and how you'd actually merge them into another branch. Does that make sense? Let's talk about what's known as a branching convention. A branching convention is a bit of a practice that you can adopt in your project, where it says your project has these branches, and these are the practices that you'd use to make new branches. A branching convention is purely, it's not enforced by Git, so it's up to you as the project contributor to actually uphold the convention. So a project will by default have a main branch, and if you want to build a feature, you'd usually branch off into its own branch called feat/x. So feat/ is this prefix is just is a convention. You could call it whatever you want, really. And x would be some sort of identifier for your feature. And you'd work on the feature, and once the feature is complete, you'd merge it back into main. At some point in time, your project will be ready for release. That is in a very stable state with completed features. So what you could do is branch off into a release branch and leave it there. Meanwhile, development can continue on the main branch. You could maybe start off a new feature and merge them in. Once that version of your code base is stable as well, you could once again merge into release. So this is a branching convention, basically. And then there's also, so sometimes projects adopt this convention of hotfixes, where if a bug is found in release, they'd branch off release into a hotfix branch, fix that, merge that into release, so that release is all good, and then merge that hotfix merge release into the main branch, so that main will include that hotfix as well. So the convention that you adopt in your project doesn't have to be as advanced as this, but what's important is that you adopt some sort of convention, just so that your project's maintainable and branches are kind of intuitive, and that you actually stick to the convention that you adopt. Now, branches can be renamed. So if we're going to stick to this convention, the branch that I made earlier, which is the adder branch, would ideally be called feat adder because it's actually a feature. So to rename a branch, you could do git. You'd have to first be on the branch that you want to rename. So you'd git checkout adder, and then you'd use the git branch-m command and specify the new name of the branch. So in my case, I'll call this feat/adder. And if you do git branch again, you'll notice that we've got feet/adder as the branch instead of adder. You could also delete branches. So if I'm just going to check out main, so git checkout main. If I make a branch, so git branch temp, and maybe I want to kind of do some experimentation on this branch, so I do git checkout temp and do whatever I want here. But if I decide that I don't really want this branch after all, and the changes that I made were for nothing, I could git branch-d temp. But bear in mind that you should be off the branch that you want to delete. So in this case, I'm going to have to git checkout main, and then git branch-d temp to delete the temp branch. So just a bit on actually deleting branches. So that's all about branching and merging and branch conventions that you might want to adopt in your project. So I hope that made sense. Does anyone have questions about branching or merging, or like a branching convention? All right, looks like we're all good. Perfect. So now we get to the part of our workshop on conflict resolution. When you make changes in branches, Git automatically kind of merges changes together when you run the git merge command. But it's sometimes possible that these merges aren't always successful, particularly in these scenarios. So let's consider this branching, this git commit graph, for example. So we're on the main branch A. We've branched off into this branch called B, and then we've done a change here as well on the main branch, and then we're merging B back into main. What happens if the same lines of a certain file in your code base have been affected in both this commit, and in both commit 2 and 1? Or if like you change a file here in commit 2, but you delete the same file over here. Now, when you like merge stuff with Git doesn't know what to keep. So should it keep changes from like this commit, or should it keep changes from this one, or should it be some sort of combination of them? So this is when a merge conflict, what's known as a merge conflict, occurs. And well, let's have a look at how we'd actually resolve these conflicts and successfully complete the merge. So as an example of a merge conflict, I'm going to make a change over. So this is the current state of a repo. I'm going to branch off into a new branch. I'm going to make a change there. I'm going to check out the original branch, make another change that affects the same lines of code as this one, and then we'll try merging this feature branch into our main branch. So what I'll do is, let's say I want to make a branch that highlights names of colors in index.html. So index.html looks like this, but I want to kind of highlight cyan, magenta, and yellow. So I'm going to call this branch feet highlights. So I do git branch feet highlights to actually make it. Maybe I'll git checkout-b to actually create the branch and check out at once. And right now I'll just go back to VS Code, add a CSS file called highlight.css. And I'll add a bit of a highlight class here. This says the background color is black, something that's visible against cyan, magenta, and yellow, and adds a bit of padding on either side. And then in index.html, I'll simply add that style sheet, CSS highlight.css, and I'll say, so I'll wrap cyan, magenta, and yellow in these paragraphs with a span with a class of highlight. So the web page looks like this now, with these colors highlighted. I'm going to commit these changes, so add everything, commit. I'm going to use the commit message highlight color names in paragraphs of index.html. So we've made a change here that affected the 3 paragraphs of index.html, specifically the 3 lines of index.html. So if I git log, You'll see the commit message, the commit hash is over there. I'm going to git show that, and I'm just going to grab a screenshot of index.html. And notice how the changes are that we've added, on our feature branch, we've added a line of code up here. That's the link to the highlight.css file. And then we've affected the 3 paragraphs in index.html. Then I'm going to switch back to our main branch, and I'm going to make another change that affects the same 3 lines of code as our feature branch. So my objective here is to generate a merge conflict. So to do this, let me git checkout main, go back to our project, and as part of this, I might just change cyan, magenta, and yellow to actually red, green, and blue. Green and blue. So I'll have to make the corresponding CSS files as well. So I'll say copy cyan as tries red.css, call this yellow.css, or rather green.css, and call this blue.css, and change the classes as well. So text blue, text green, and text red. So at this point, if I look at our project, notice how the paragraph is red, green, blue. And the highlights are gone because the highlights were made on a separate branch. If I look at the git status, you'll notice that, okay, so we've changed index.html and added blue, green, and red.css. I can add our changes and commit these as replace, use red, green, and blue paragraphs on index.html instead of cyan, magenta, and yellow. So at this point, we've made, 2 conflicting commits on separate branches. And what we'll try to do now is to merge our new branch onto our main branch. So to do this, once again, we'll have to do git merge. We're currently on main, so we've got to merge feed highlights into main. So git merge feed highlights. And git says, okay, so we've got a merge conflict. It doesn't know. So we've made changes on feed highlights and on main. We've made changes to index.html on both feed highlights and on main, so it doesn't know which of these to actually preserve. This is the diff of the change that we did on main. And so let's have a look at this diff. The other diff, the 2 differences on index.html. So this is on main, and the other diff, which I copied earlier, is on the feature branch. So we notice that the paragraphs affected by both commits are down here, so there'll definitely be a conflict here. And up here we've added highlight.css after the added.css line. So this change should be successfully merged by Git into our main branch. And then Git should also be able to automatically merge this change as well, because these lines of code haven't been affected up here. So let's continue with the merge. So once again, remember we did git merge and then feed highlight, and it said we've got a merge conflict. So let me just merge feed highlight. It says we've got a merge conflict in index.html. Now, when a merge conflict occurs, this is what happens. Git merges the 2 branches as much as possible. So it should automatically do the changes that don't conflict with one another. And then it stages entire files that are successfully merged, And then if conflicts occur within a single file, it simply marks those conflicts like this. So we'll actually have a look at this, but if you do git status, you'll notice that we've got a new file. Interesting. Yeah, so we've got a new file called highlight.css that we added over here. So this is a file that can be successfully merged because there are no conflicting changes. So that has automatically been staged. So it's listed under changes to be committed, but over here it says both branches modify index.html. So let's head over to index.html and have a look at what it looks like. Notice that git changes, well, git automatically adds this marker, so that's what this is. The top half of the marker says this is what's on the current branch, and the bottom half says this is what's on the branch that's incoming. So in this case, it's feat highlight. So on the current branch, we kind of changed our paragraphs to red, green, and blue, and up here we highlighted paragraphs. So we'd obviously see both versions of the code here. Now to merge, to actually resolve this merge conflict, all that we have to do is fix this bit of code. Now sometimes it's as simple as accepting either of these, but in this case we want a combination of them. So we want the highlight to be around red, green, and blue. So what I can do is wrap red, green, and blue in a span called highlight, and simply remove the rest of the text here, including the commit marker. And just like that, we've successfully resolved our commit, and a highlight is actually on the red, green, and blue paragraph. So does that make sense? Merge conflicts resolved. And we've got to commit our changes now, so we can simply add all of these changes and git commit again. This will open the text editor that says, okay, an auto-generated commit message that says this is where we merge the branch feat highlights into the main branch. So we could just close this off to use this commit message. And you'll notice that if I git log, the merge commit has actually been done on main, and the merged changes actually appear on main as well. So that was a lot. Did that make sense? We generated a merge conflict by modifying this, modifying the same lines of code on both of these commits, and then we resolved that merge conflict that arose when we tried to actually merge our changes using the git merge command by modifying the file, specifically where git added the merge conflict marker, and literally just committed the change. So I hope that made sense. So that's what conflict resolution is all about, really. Once you fix the changes, you'd run git commit. And then at any point in time, if you're in the middle of the merge and you want to abort your change, you could do git merge -abort, and you'll revert to the state at which you were before you actually started the merge. So I hope that makes sense. A couple of points when using the terminal interface to Git. So you'll notice that if you run git log, we've made quite a few commits, and it's not enough space to actually display all of it. So what you'll see is an interface like this with a colon at the end. And this means that you can use J and K to scroll up and down, Control D to scroll up and down by multiple lines, and then Q to actually exit. So that's just something that you should probably know. And also, as I said, I can't say this enough, check git status often, because that way you can actually orient yourself in the context of your Git repo. So in this case, it says I'm on branch main, and it says I don't have anything to commit, but I think we saw earlier how git status shows a bunch of files that actually changed when there are changes. And finally, if you want to view at reference documentation for each command, there's the git help command, which lets you view some help docs. So if you want to figure out what else the commit command can do, you could do git help commit. And on Windows, it opens like a web browser that shows you some stuff, and on macOS and Linux, it'll show it in line. And once again, you can use the same controls, J and K, Control D and Control U, and up to actually view the documentation. Regardless of what you actually view, the contents of the help doc is the exact same. So that's how you branch off of your main. Well, that's how you'd branch. That's how you'd merge. And that's how you'd resolve merge conflicts. How would you actually collaborate on Git, though? That's the next question, because you want to use Git for collaboration. Well, you've got to host your repo on a service like GitHub or GitLab or Gitbucket or Bitbucket. So we'll use GitHub for this demo. You'd obviously have to visit github.com and create yourself an account. github.com/login, or rather join. Just bear in mind that the email address that you specify here is the actual email address that you configure at the start of your repo. So it's this email address over here. But you can obviously change this as to whatever you want. Just rerun the same command and you'll be good to go. Once you've created a GitHub account, you'd want to create a repo on GitHub. And to do that, you'd press this little plus button over here and go new repository. And you'd specify the name for your repo. So in this case, I'll call it 2021T1-fundamentals of Git. Fundamentals of Git. You could give it an optional description, etc. And I'm just going to leave everything in their default, except I'd make this a public repo on the DakinSec GitHub account. And at this point, what you'd want to do is to link the local repository that you made earlier and the repository that you created, the remote repository that you created just now. And to do that, there's a couple of commands that you can run. So to push an existing repo from the command line, literally just do git remote add. You literally just copy paste that command over there. Now, so remote is basically a remote repository that's linked to your local repo. And you can push your changes to this. So to push your changes, literally git push -u, then the name of the remote, which is origin by default, and then the name of the branch that you want to push. In this case, it's main. And you'll notice that, oh, oops, I've got to log in again, I guess. 1 sec. Interesting. Oh yeah, of course. In my case, due to my configuration of Git, I'm going to have to use the SSH version of this. So this is something that you might not have to do. But once again, you do git push u origin main, and you'd see some output like this. And now, if you actually reload the repository online, you'll notice that your code's actually there. And you'll notice that the list of commits that you made are also there, and you can view the diffs of these online as well. So that's how you'd host your GitHub, your Git repository online. If you've got a contributor, and I'll use this other machine to represent someone else who's contributing. For them to actually contribute, they'd have to clone your repository from wherever it's made. So in this case, it's on GitHub. So I'm just going to copy this URL and on my remote machine, paste it. Then I'd specify, so I'd use the download little button here and copy this URL. And then you'd use the git clone command with that URL to actually download the repository locally. So let me open PowerShell or like any terminal application, cd onto my desktop, and use that URL to clone my repo. So git clone and then specify the URL, and you'll notice that it's cloned into fundamentals of Git. At this point, I can cd into that folder and start index.html, for example, and this will open index.html in the contributor's computer. So this is a different computer, and all of our changes are there. This is all good. So once you've cloned the repo, you can go ahead and make your own commits. So in this case, let's say the contributor changes index.html. So I'm going to open this folder in VS Code. So index.html over here. And let's say the change that they want to do is to remove this paragraph that says that there are changes to sorted content. Their process will be the exact same. So they do git status, and they'd see that they've modified a file. They could do git diff and see the actual changes. In this case, it's kind of barely legible, but that's a red minus sign that represents that they've removed this. They can go and git commit -m and say, oops, snooze. They could say remove paragraph that describes content of Git. Describes content of index.html. So bear in mind, this is an entirely different computer, but I forgot to stage my changes and commit them. So if you have a look at the git log now, if they had a look at git log now, they'll notice that my changes are over here, and then their changes over here as well. Oops. And if we have a look at the actual full log, you'll notice that, okay, so my changes are over here, and the author is like me, and then the author of this change is a different author. In this case, I've configured Git on this machine to use a different credential, a username and password. All good. So now a collaborator has made a change, but at this point, if I switch back to my computer and I do git log, you'll not really see that change, and you'll not see that change online as well. And that's because once you make a change, you're supposed to push your change, and you do this using the git push command. And you'd see something like this that says it's being pushed. And now, if you reload the page, the repository online, you'll notice that the change that we did on a different computer actually comes up, is listed over here. So if you go to the list of commits, it'll be the first commit that's listed over here. And then I would still not see this change because to pull the changes down, I'd use the git pull command. And it's only now that I'll actually see this change, and it's only now that I can reload this page and that paragraph is gone. So that's really what collaborating with Git is all about. You do it's a sequence of commits, and then you'd push those changes, and then someone else would pull those changes, and you just keep doing that until your project's pretty much done. Bear in mind, committing is not pushing. So committing changes saves the changes locally, but to actually propagate those changes online, or like wherever your remote repository is, you have to push those changes. So it's just something to bear in mind. Now, you can also, if you branch very often, you can keep working on multiple changes together. So like think of an architecture like this, a branching, a Git graph like this rather, where you've got someone working on this branch on their own commits, and then you've got someone else working on this branch and a bunch of other people working on this branch. They'd individually do their own commits, and then at the end they'd kind of merge everything together, and that's how like collaboration would ideally happen on Git. And that's how Git lets you work on multiple features simultaneously. So yeah, that's how collaboration works. And by the way, if you use Git and you want to collaborate with somebody on a project, you'd want to go to security, or rather settings of your project, and head over to manage access and specify the GitHub usernames of the other collaborators that you want to invite to actually work on this project. Because if not, they won't actually be able to push the changes through, because the change will get rejected. So you've got to kind of give them access. Now, in Git projects in general, there's a couple of things you'd want to do. Firstly, you'd want to specify what's known as a gitignore file, depending on the complexity of your project. How much time do we have? Well, 2 minutes, but anyways, you want to specify a gitignore file. And a gitignore file literally lists a bunch of parts that Git shouldn't really track. So an example of this is when you've got files that are kind of regenerated every time you build your project. And as an example of this, I want to use npm to install a couple of packages. So I'm just going to do npm init. Through these, I'll do npm install a package called sakura.css and maybe canvas confetti to add a bit of visual effects to our project. So I'm going to go ahead and make a couple of changes in index.html to import these dependencies. So I'd say like link. Oh, something just happened. Are we still here? I accidentally locked my computer. Are we still recording? And is the video still going? Oh, good. Sorry. Anyways, so I'll do link, and then I'm just gonna import the actual packages that we added. So 1 second. And then in greet.css, in JS, greet.js, or rather in adder.js, I'm going to add a bit of confetti when the user performs an addition. So I do something like this. So if I reload the page, it looks much nicer because of the sakura.css dependency. And then when you do an addition, that will happen. It's pretty cool. So this is an example of us using a tool, in this case npm, to make changes to our projects. And as you do advanced projects like with the JavaScript ecosystems or with C# ecosystems, or pretty much any software framework really, you'd have to use tools like this. And sometimes tools like this, when you install dependencies, for example, they do stuff like make a bunch of extra files in your folder. So in this case, I've got a node modules folder, and it's got the actual dependencies that are downloaded. And these are files that you wouldn't want to actually commit to your repository because they are automatically regenerated whenever you run the npm install command. So this is an example of a file that you'd want to ignore using the gitignore file. So if you do git status, you'll notice that the node modules folder is actually listed as a change, but we want Git to ignore it. So what we do is we'd say at the root of our repo, let's make a git ignore file, and I'd add node modules as a file path to it, and you now notice that if I do git status, that node modules is no longer listed down here. Yep. So that's an example of how you ignore certain files from being committed to Git. So once again, I'm just going to git add everything, git commit. I'm going to call this add sakura.css and show confetti upon addition. And once again, I'm going to have to git push to actually make the changes appear on the remote repository. So once I push these changes, you'll notice that they actually appear. And you'll notice that the node modules folder, despite being in the actual project folder, isn't online because we added it to the gitignore file. There's a pretty cool website called a repo on GitHub called github.com/gitignore or github/gitignore. And this has a bunch of common gitignore files that you might want to use. So in my case, I'd use the node.js file because that's what includes the node modules folder. So generally, you just copy the contents of this file, replace them well, you paste the contents into your own git.ignore file, and you just commit this. It's a one-time change, and you'd be done with it. So let's git commit m, git add everything, and commit -m that says add standard. So use standard Node.js git.ignore file, and git push to make the changes appear online. A couple more changes that you'd want to do. I know we're running a little bit over time, but we're almost done. A couple more changes that you want to do in your projects is have a bit of documentation at the root of it. So you'd have what's known as a README file. And a README file is what's called readme.md, and it will describe the actual project itself. So, for example, this is the README file that I'll use for our project right now. I've added a bit of a comment for myself to actually update this later with the video recording. So that's what a README file is. And then you could do a contributing.md file. And this describes to new users of your project, what they must do to actually get started. So in our case, the contributing.md file would be something like this. So it goes about, it describes the prerequisites. So we need Git, and we also need npm to install those dependencies. A bit of a recommendation on VS Code. How to get started. So clone this, then npm installed, then you can go ahead and launch the index.html file. And also, you can use this file to document any conventions that you've instituted in your project. So branching conventions, commit conventions, any of those. Finally, if it's applicable to your project, you'd want to use a license as well. So that'll be the file called license at the root of your repo. And if your project's open source, there's a pretty cool website called choosealicense.com that lets you kind of copy a bunch of common open source licenses. So in this case, I'll go for the MIT license, paste it in here, substitute the year and maybe the name of the owner as well. And yeah, so this is the license file. And depending on the size of your project and the number of contributors, you'd also might want to add a bit of a code of conduct. This link says how you might go about it, because there are a couple of standard code of conducts that you can either use or base your code of conduct based off, right? So we've made a couple more documentation changes. So let's do git status. We see that we added these files. I'm going to git add, git commit -m that says add license, add a readme file, add contributing.md, and add a license. Once again, changes are committed, so git log will show our changes. I'm going to git push them, and they should appear on our remote repository. A little special thing about a README file is that it gets rendered by GitHub. So this is the actual content of your README, representation of your content of your README file. So it's pretty cool. Also, the .md files are of this format called Markdown, which is an easier, more readable way to write HTML. So the GitHub flavored Markdown specifications over here, so you should be able to visit that as well. And finally, we've been using the terminal to interact with GitHub so far, but you can also use a graphical client as well. These have their pros and cons. Terminals are very fast and they're universal, which means the commands that you'd use are common across all platforms. And if you want to do advanced stuff like scripting and automation, you'd have to use a terminal. But then again, if you want to use a graphical client, it offers better visualization of commit differences and the repository in general. So SourceTree is a pretty, it's a free graphical client that you can use. So in my case, I could open the project within SourceTree, and you'll notice that the div that's displayed, so let me go add, I'm going to browse to the location of my actual repo, that is my project. Notice that, oops, that ought to be just my project really. You'll notice that this offers a much nicer kind of view of the repo. It offers visualization of the branch as well, and kind of and a bunch of convenience features really that make committing a bit easier. So you might want to consider using this as well, or alternatively, instead of the terminal as well. By the way, if you want to view the Git graph with the terminal, you could do Git log, one line, and graph, and that will show you basically the same GitHub graph, commit graph that you see over here. But so there's quite a few graphical clients to choose from. Some of them are listed over at this link. You can filter them by platform as well. But what's important here is that you know the underlying Git concepts, and ideally you'd be aware of the terminal commands, even if you're using a GUI, because you could always have to fall back to the terminal sometimes. So yep, that's a bit of a review of what we've done, what we've discussed today. We've installed and configured Git, created a repo, made commits on it. We branched off of the main branch. We've merged other branches into our main branch. We've resolved commits, merge conflicts rather, that occurred during that process. And we also published the repo to GitHub, and through this, we can have other collaborators, like the collaborator on this computer over here, actually contributing to your repo. So at this point, if the other collaborator kind of runs git pull, they'll pull your changes through, and you'll notice that their git log will now show the changes that you made. Their extended git log will now show like your credentials as well, and when you actually made the commit. And their project will also include the markdown files that you made. Also, a bit of a tip: if you're using Visual Studio Code, it has a bit of a command called the Markdown Preview, where you can open a Markdown file like to the side and edit it as you actually view the changes. So it's pretty cool and super useful when you want to alter Markdown files. So yeah, we covered a lot today, and this should be a good starting point, starting knowledge of Git for you to be able to make your own like Git projects and to be able to contribute to existing Git projects. And with that, I mean, we've pretty much come to the end of the workshop. I'll stick around for a little while, and you should be able to kind of unmute yourself and ask any questions if you have any, and let's kind of have a chat if necessary. But that said, I mean, thank you. Thanks a lot for attending. We really appreciate your feedback, by the way. So there's a bit of a form that you can use to specify feedback. Let me just paste it in the chat, which is over here. And so thank you so much for attending. Appreciate your time, and I hope you learned something useful. So once again, we're the Deakin Software Engineering Club. We host skill workshops like this, hackathons, projects, and quizzes and whatnot. And you can join us at bit.ly/dsecjoin. So I could actually paste that link as well if you'd be interested in joining stuff like this. Join. That's all good. Also, a bit of an upcoming project that we have. If you have a look at our GitHub repo, which is at GitHub organization, which is at github.com/deakinsec, you'll notice there's a bit of a repo that says Deakinsec website. This is our club website, but it's updated 3 years ago. So we're planning to have a bit of a project where we collaboratively develop this website using Git and using a bit of front-end static technologies. It's still being planned, but it should be available for all DSEC members. So if this is something you'd be interested in contributing to, it should give you a good opportunity to actually use Git and to also learn a bit of front-end web dev. So yeah, if you'd like to, we'd love contributions of DSEC members. You can join over at DSEC Join. But anyways, that's pretty much it. And that's pretty nice outside. So as I said, I'll stick around for some time. If you have any questions, you can definitely unmute yourself and let's talk about them. But otherwise, thanks for attending, and yeah, have a nice rest of the evening.